everyone, welcome you back in my geography class. In today's video, we will know about the nebular hypothesis of class 11. So without wasting much time, let's get started. In the last video, I discussed about the gaseous hypothesis by Immanuel Kant. Now, Laplace, what he did, he actually modified the Kant's gaseous theory and gave it a name, that is the nebular hypothesis. Now, who was Laplace? Pierre Simon de Laplace. He was a French mathematician. He gave his theory, that is a nebular hypothesis, in 1796 in his book The Exposition of the World System. Here he tried to expose the world system. That means he tried to explain about the formation of the solar system, the formation of the Earth. Now Laplace actually modified the Kant's gaseous hypothesis. So the nebular hypothesis is just a modified version of the Kant's gaseous hypothesis. Now we will see that Laplace has propounded this theory without any mathematical calculations. Now we will see that there are some assumptions that was made by Laplace while he formulated his nebular hypothesis. So let us understand what are the assumptions. In the last video, I told you that the theory of Kant, that is a gaseous hypothesis, was rejected and criticized because there were certain defects. Now to remove the defects, Laplace has assumed certain axioms to postulate the theory of nebular hypothesis. Why? So that he can solve the riddle of the formation Now let us see that which are the assumptions that are made by Laplace. The first assumption was that there was a huge, hot, gaseous mass from the beginning called nebula. Whereas Kant said that the mass was motionless, cold, and it was not rotating. But it is, here we will see that Laplace said that the mass was, from the beginning, it was huge, hot, gaseous mass. So it has solved the problem that from where the nebula got the heat. The second assumption was that the nebula, hot gaseous nebula, were rotating. It was rotating around its axis. So again it solved the second defect, that from the initial period only it was rotating around its axis. The third assumption that was made by Laplace is that there was radiation which led to release of heat from the outer surface of the nebula and as the heat is released, we can see that it led to cooling of the nebula due to contraction. The size of the nebula decreased. In Kant hypothesis, we have read that from the initial period only, according to the Kant hypothesis, the mass was cold and motionless and it was not rotating. Why it started rotating? Because of collision. Due to collision, heat was formed, and due to for collision there was friction, then it led to heat, and as the temperature rise we can see that the rotatory motion, there was a random motion which led to the rotatory motion. But here we can see that the size did not expanded. The nebula was, from the initial period, it was a huge hot gaseous mass and it was rotating. Also we have read that as more and more heat increased, temperature increased, the size of the nebula expanded. But here in Laplace concept we will see that the size of the nebula is getting decreased. Why? Because the heat is getting released due to radiation. Now let us understand the concept of Laplace. Now based on the aforesaid assumption of Laplace, let us understand the theory. So Laplace said that from the beginning the primordial matter was not scattered in the universe as stated by Kant, but it was a hot, huge, gaseous mass called nebula. So you can say that it was a hot gaseous mass that is called a nebula. Now this nebula is rotating. From the initial period only it was rotating on its axis. Now what happened? The nebula from the outer surface is started radiating the heat. So from the outer surface, due to radiation, it started radiating the heat. That means it started losing the heat. So we can say that due to radiation, it loses heat from the outer surface. As it loses heat from the outer surface, what will happen? It will start getting cooled. Now when it starts getting cooled, it will contract. So due to cooling, we will see contraction will happen. Contraction will occur. So we need to cooling of the mass. The mass will contract, and as it will contract, the size of the nebula will decrease. Decrease in size of the nebula. Now, as the size is getting decreased due to contraction, we will see that it will lead to increase in angular velocity. That means the rotation speed of the nebula will increase. Now, as the rotation speed will increase, we will notice that with more increase in angular velocity, the mass of the nebula will shift around the equator. That means we can say that around the equator, that means the equatorial zone, the mass of the nebula will be bulging. So, you can say that the mass of the nebula around the equator is bulging here. Now, let us see what will happen next. Now, with the increase in angular velocity, we will see that centrifugal force will increase. I already explained you about the centrifugal force. There are actually two forces which are acting. One is centrifugal and the other one is the gravitational, or we can say the centripetal force. Just let me explain it again. Suppose you have a string and you have tied that string and you have tied one stone in that string, and with that string, as you are rotating the string, you will see the string is constantly rotating, right? That is referred as a centripetal force, and we can also say the center seeking force. So what will happen? It will, like as you're rotating it, it is attracted towards the center, right? And as you will just leave the string, you will see that it will just go away. So that is referred as the centrifugal force. So centripetal force actually leads to the centrifugal force. So as we can see that angular velocity is increasing, the two forces like centrifugal force is increasing, and due to the gravitational force or the centripetal force, we will see that the matter of the nebula will be attracted towards the center of the nebula. So at this time we will say that the gravitational force or the centripetal force and the centrifugal force are opposed to each other. Now, a time will come when the centrifugal force will be equal to the centripetal or the gravitational force. What will happen? Here we can see there are some excess matter around the equator. This excess matter which was around the equator will get separated into a ring. So this excess matter will get separated as a ring from the equator. So we can say that the excess matter around the equator will get separated as a ring from the nebula, and it will become weightless. Now, with increase in angular velocity, with constant cooling of the mass, the centrifugal force will exceed the gravitational force, and this will lead the rings which are already separated will move away from the nebula and will start rotating. Now how it will happen? This is the nebula. This nebula, there's a nucleus. It is constantly cooling down. It is still cooling down, and this ring, outer ring, is also cooling down, and it is also, we can see that contraction is happening, so it cannot move around the nebula. It is still, it is constant. So what will happen? It will get separated from the main nebula and it will move around the nebula, and it will be only one ring which will get separated. Now this is the center. The center will remain as the center of the remaining mass. At the center, that is the remaining mass, will remain as the sun. So it will be the sun. So the mass that is remaining at the center will remain as the sun, and this ring, and then this ring will break up into 9 rings and will form planets. 9 planets. There will be only one ring that got separated, but this one ring will break up into 9 rings and will form planets. It is referred that the matter of the ring, they will collapse and they will condense. Condensed into hot gaseous agglomeration, and this formed the planets. Right? So this was the theory given by Laplace. So we can understand there is a quite lot of difference in the theory given by Kant and Laplace. Laplace theory was accepted, but still there were certain defects in Laplace theory. Let us know what were the defects of Laplace theory. The first defect of Laplace theory was that he said that from the beginning the sun was there. It was a hot rotating mass, but he cannot explain the origin of the sun. He cannot explain the source of heat and also the origin of rotation, like from where the rotation started. According to Laplace, there was some materials here at the equator, right? That was around the sun. So if that is so, still now there should be some materials around the sun. That means there should be a bulge. Bulge should be there, but we cannot see any bulge around the sun. The third defect of the nebular hypothesis is that he could not explain that how from one ring 9 rings were formed. Why only 9 rings? And how it led to the formation of 9 planets. These were the defects of the nebular hypothesis. I hope so all of you understood the nebular hypothesis propounded by Laplace, and there was a hypothesis which was propounded by Immanuel Kant. So what you will do, you will follow the PDF that has been provided in the description box. Read your NCERT. If you like my content, don't forget to hit the like button. If you have any problem or any suggestion, you can comment in the comment box given below. If you are new to my channel, don't forget to subscribe my channel and to hit the bell icon for further notification of the upcoming videos. Thank you. Till then, stay safe and stay at your home.